Nothing more intimidating than Darth Vader with allergies. Hey guys, and welcome back to This Week in STEM. I'm Steph, and why am I wearing a Darth Vader costume? Because Star Wars! If you've been living under a rock the past week and totally missed the second trailer, go watch it now, it's so good. I'm still emotionally dealing with the last 15 seconds of seeing Han and Chewie together again! And I know I'm wearing a Darth Vader costume, but Han will always be my favorite. The most devastating part of my childhood was finding out that Han Solo and Indiana Jones were, not real, and that the guy who played them was way too old for me. There was a Jennifer Lawrence gift that pretty much summarized my reaction to seeing Han and Chewie again. Yeah, that's about right. But yeah, Han shot first. Now, moving on to the actual STEM news, which I'm sure is why you're all actually here. This week, our first story deals with the ultimate Kickstarter, the Kickstarter of life, in fact. A new study this week is bringing us one step closer to figuring out how life may have literally exploded onto the scene. Our story actually begins in December of last year when a team of Czech researchers were looking into the origin stories of life itself, specifically one involving asteroids and comets. And not just any comet or asteroid will do, no. The one that we're looking for must have a specific molecule called formamide. Also known as NH2CHO, formamide is actually really abundant throughout our universe, specifically in massive interstellar clouds. Formamide is actually believed to be a vital component in all planet-forming star systems. The Czech researchers concluded that the energy generated from an impact of a comet or an asteroid onto Earth's surface would be enough to instantly convert the formamide to the, quote, molecular letters of the genetic alphabet. Poetic. However, there was still just one problem. While this process definitely generated the building blocks of the DNA, we're still missing the nucleosides or sugars and the phosphates that make up the actual backbone of the double helix structure of DNA. So this part of the question was left unanswered until now. The latest study, conducted by a team of Russian and Italian researchers and led by astrochemist Rafael Saldino, can provide at least half of the fix for that problem. They found that when formamide is bombarded by solar winds, it can produce the sugars or nucleosides necessary for the double helix structure. To test this theory, the researchers combined formamide with ground up meteorite dust in vials and then stored them at space-like temperatures, aka super cold temperatures. They then zapped each vial with a proton laser in order to simulate the supercharged particles that you experience in solar winds. Now, that was the easy part. Then comes the super hard part of sifting through the dust in order to look for organic compounds. As fun as I'm sure that was, they actually found some really great results. The various combinations of formamide and meteorite dust yielded 25 different molecules that are essential for not only DNA formation, but for life as we know it. Oh, what about the other half of the double helix structure, the phosphates? Never fear, Saldino has a theory. Phosphates are inorganic compounds that are found in minerals on rocky planets, such as ours. Basically, the planet throws a super awesome party and offers to bring the phosphates, and then tells the asteroids it's BYOF, bring your own formamides, and then boom, life as we know it. Now this hasn't been totally confirmed yet, so Saldino is actually developing an experiment to test this theory out. So what does this mean for life outside of Earth? Well, Saldino says it's feasible, but not easy.
But just because the molecules required for the origin of life are very easily synthesized, that doesn't mean that life is equally easy to create. Molecules are one thing. Life may require time, opportunity, and much more complexity.
Moving on to exciting medical news, a paper recently published in Nature suggests that an HIV vaccine may be possible. Now, when a person is in the process of being infected by HIV, antibodies are formed to combat this, but once the disease takes hold, the antibodies kind of disappear. There are three main types of antibodies, but the most important one that we're going to focus on is called 3BNC117. Very creative name. These antibodies block first contact between the virus and the cell that is trying to infect. In lab experiments, researchers found that 3BNC117 was capable of neutralizing 80% of the virus in HIV samples. So what does it do for humans then? For human trials, researchers gave 17 different HIV-infected patients various dosages of 3BNC117. Then, each patient's immune system was monitored for about a month after treatment. Now, the study yielded some promising results and some problems that still need to be fixed. For the patients that received the highest dosage, the HIV found circulating in the blood decreased from 8 to 300 times over the month following the treatment. Some patients developed virus variants which managed to elude the antibodies, but some of the virus variants didn't. This suggests that the virus can only combat the antibodies to a certain point. And now for the bad news. The patients that received smaller dosages saw almost no effect, meaning that you have to have a super large dosage for this to work. Now the largest dosage was equivalent to about a teaspoon of the antibodies, and while this may not sound like a lot, antibodies aren't very big, and to fill up a teaspoon with them takes a lot of effort. Plus, these antibodies don't come cheap. On top of that, remember that the lab study only neutralized the virus by 80%, leaving 20% still unaltered. For me personally though, no matter how you look at it, this is a huge step forward, and I can't wait to see if this can develop into something that will save so many lives. Moving on to something that's quite literally out of a science fiction novel. Like I said last week, I'm a huge Arthur C. Clarke fan, and if you are too, you probably have heard of a space elevator. At the American Physical Society meeting this month, West Virginia University physicist Leonardo Golubovic, I hope I got that right, and his student, Stephen Knudsen? What's with the names, people? Anyway, those two gentlemen with the really hard to pronounce names proposed a new concept that may possibly bring space elevators closer to fruition and out of science fiction. Maybe. A girl can dream, right? Now, Arthur C. Clarke was not the first gentleman to propose the idea of a space elevator. A Russian engineer named Yuri Artsutnov, what is with these names? First proposed the idea in his 1960 article, To the Cosmos by Electric Train. Since then, the idea has evolved a little bit, but most concepts still have the same basic setup. The concept involves an anchor offshore platform that's tied to a super long tether that reaches into space about 62,000 miles to a massive counterweight that's in geosynchronous orbit about the equator, also known as a geostationary orbit. Hank Green actually does a really good job at explaining this concept, so if you click on the annotation here, it'll take you to his video, and hopefully that'll clear things up maybe a little bit better than what I can do. Plus he has prettier graphics. So what makes this new design so revolutionary? Well, the two gentlemen are quite literally putting a spin on it, because they're spinning it. By using this spinning design, they effectively eliminate the need for additional thrust to push the cars up and down. Additionally, this concept doesn't require an anchor point, meaning that it's not limited to only rocky planets and can be used on gaseous planets like Saturn or Jupiter. Now, this concept was first thought of back in 2009, but thanks to some super complex computer modeling, it's been matured a lot along the way. So why would space elevators be a good thing? First of all, it means it would require less power to take large payloads to space, aka no more using rockets, aka cheaper. Additionally, there would be fewer negative environmental impacts since you're using electromagnetic energy rather than rocket fuel. It's also quieter, and the tech has some aspects that would be scalable, which is always a big buzzword for engineers, and we love it when things are scalable. Now, despite all these really awesome benefits, we're probably still a really long way off from this ever becoming a thing. Imagine that you're standing on a playground and you have a ball on a rope. Now you start spinning just fast enough so that the ball is extended and the rope stays taut the whole time. So now imagine that you're the Earth, and the ball on the end of the rope is a super massive counterweight that has to spin at the same rate as the Earth's rotation. Long story short, you need a really strong tether. And the fact of the matter is we just don't have the materials yet to build such a strong tether. The closest thing we have today are carbon nanotubes or graphene, but neither of these things has been built in such a huge scale that would be required for the tether. The next best thing might be the diamond-like nanothread that's being developed at Penn State, but the problem is it's just that, being developed. So yeah, a little bit before it's ready to go into production. Another big issue that exists with the whole current concept is the fact that the anchor platform would have to exist at the equator. Now, there's not a whole lot of land at the equator, so it would probably have to be floating on the ocean, which can be pretty unpredictable. A lot of companies see these problems as pretty big setbacks, most notably Elon Musk. Although that would make sense since he's just spent a lot of money developing rockets to put stuff into space, but he's actually been really cool about it, saying that he would be happy to see somebody prove him wrong. Speaking of Elon Musk's rockets, one of those launched this week. On Tuesday, a Falcon 9 rocket launched the Dragon capsule to the International Space Station full of supplies and a couple other really fun things that we'll get to. Dragon aside, this mission was important because it was SpaceX's second attempt to land its first stage reusable rocket on its drone ship that just read the instructions. Now, for those of you that don't remember, a couple months ago they did manage to hit the drone ship, and then they had what Elon Musk called a RUD, Rapid Unscheduled Disassembly. We like our acronyms. This time, while very close, they managed to land it, and then it hit a little too hard and tipped over and then went boom. While SpaceX may not have stuck the landing, this is still a huge step forward for them. Quick rant time for all those news outlets that are saying that SpaceX had a failure and it was catastrophic and making a big joke out of it. I hope you step on a Lego. Do you understand how difficult this is? This isn't trying to land a bottle rocket in your backyard. This is lines and lines and lines of code and trial and error. And you know what? We had a couple trials and we had a couple errors, but this is still incredible to launch a rocket and then potentially land it on a drone ship to be reused. Do you have any idea how big this is? TLDR, space is hard, educate yourselves. Okay, I'm done. Now that the Dragon capsule has been successfully plucked by the International Space Station, the astronauts can start unloading the over 4,000 pounds of cargo from it. Yay for microgravity! While yes, most of the cargo consisted of supplies and hardware for further testing, it all consisted of a teeny tiny new crew, a bunch of moustronauts, as they're called, for the rodent studies on board the International Space Station. And the most critical piece of hardware, in my personal opinion, was the new espresso maker that's going on the International Space Station. Italian company Lavazza specifically designed the espresso maker for Italian astronaut Samantha Christopher Reddy. While espresso is delicious, there is some science behind this. A group of researchers sent 6 prototype espresso cups up to the International Space Station. These cups are special because they use the surface tension, so the astronauts might be able to drink out of these cups and actually sip their espresso rather than sucking it through a straw. And Samantha seemed pretty stoked to get her espresso machine, posting this super awesome picture. Look at her, she's decked out and channeling her inner Captain Janeway, and I'm just so proud as a geek at this moment, even though I'm wearing Darth Vader stuff. How cool is that? Maybe one day I'll be able to wear this get up on the International Space Station. How cool would that be? So that's it for this week in STEM, guys. Thank you so much for tuning in. I really appreciate it. If you don't want to get force choked, feel free to give the video a big thumbs up and subscribe to the channel. Quick channel announcement. I know I said I was going to do Wednesday videos, but I think I'm going to pull back on those for a little bit. I'm really sorry. I really thought I'd be able to do 2 videos a week, but I'm just kind of kicking my own butt right now because I do work a full-time job and I put a lot of effort into these videos to make sure they're correct and researching them and editing them and like outlining them throughout the week. So I don't want to lack quality because I'm trying to get videos up just because I said I was going to. So you'll probably still see 1 or 2 Wednesday videos every month, but I just can't keep doing it. I'm so sorry. But since TWISTEM isn't going anywhere, don't forget, if you find any really cool STEM news stories throughout the week, feel free to tweet them at me at Steph43 on Twitter using the hashtag TWISTEM, and they just might end up in next week's video. Also, if you want to check out any of the stories that I talked about in today's videos, I have links for my sources down below in the description, along with my social media links and the links to the artist that does my lovely title card, Mr. Rob Cabrera of Creative Squirrels. So please go check him out. He's awesome. But that's it, guys. I hope you have a wonderful week, and I will see you next time. May the Force be with you. Get the Velcro to stay on the thing. Researchers were investigating. Team of Czech researchers were researching. Good job, Captain Obvious! The latest study, conducted by a team of Italian and Russian. Why can't I say Russian? The latest study, conducted by a team of Italian and Russian. My hands are sweating like crazy in these gloves, but I'm like halfway through, so I gotta stick with it. Medical news. A paper. These antibodies. I almost did it again.